Hi, welcome back to Mini Rust in Rust. This is video 36. This is video 36, and we are still writing a mini programming language that looks a lot like Rust in Rust, which can get confusing, by the way. When we're talking about values of type i32 that contain themselves an i32, we have to remember that one of those is like a Rust i32 and one of them is a Milk i32, which is our programming language. But so far we haven't got too confused with that. That will probably get more confusing as we deal with things like functions. That's where I find this stuff gets confusing. Anyway, we have successfully got a while loop to work, and we're just making our evaluator a bit better. And we've noticed there is a gap in our language, which we should probably fill in, which is just being able to deal with blocks of code that are just standalone, just a curly bracket, then some code, and then a closed curly bracket. And we should be able to parse those things and then evaluate them. And in Rust, they just evaluate to whatever the last statement inside the block is. So let's try parse block. Something like, test something like this. It's going to be parsing a block. I mean, it's just parsing a block, right? And inside that block could be anything. So let's have just a number to make it as simple as possible, like so. And it's going to come out as a thing we're going to call a block. Oh no, that already exists, and it takes in a list of statements and the final expression. In this case, the list of statements is going to be empty. So I guess let's put a statement in. Let's put in a statement that just says the number 3 and then the number 287. So it's going to be a vec containing let's have 2 statements in there. Like so. It's going to contain a couple of things, and then it's also going to be a number, which is 287, and the position of that is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. Did I just count that wrong? 0, 8. Yep. So 8, and it goes on for 3 characters, and we need a comma. Alright, so when we run this test, it fails, surely, because, it says we can't yet parse something that starts with a curly bracket. Also, this thing is going to be wrong, so let's fix that too. It's going to be a box containing a thing, and then another box containing another thing, and that thing is going to be a syntax tree statement. And that's going to contain like a box, another box of a syntax tree leaf. Now, why is there a thing called leaf? Like my friend John was asking me, why are we doing this? And I think this is something a lot, like I'm not going to get my head around it now, but this is something that I think we should think about. Like, why have I got this thing called leaf token? I'm fairly convinced that something like that should exist. But I think maybe I've given it a terrible name. 0, 1, 2. And we can probably give it a better name, and that would help us. So that was one thing. It's inside that one statement that's inside that block, and this block actually has 2 statements inside it. So the second one is the statement 3, semicolon, which starts at 3, 4, 5, goes on for 1, like so. Alright. Fine. That's what it should look like. What it actually looks like is not yet implemented. So let's look at where it's not implemented and ask ourselves why not. So when we are parsing and we find a token of type int then we parse it as like an int. And when we find one of these things, they can't come first. So this is our first kind of non-trivial parse. Is that right? No, this is a try. Why are we in try from? Oh, hold on. Yeah, no, what are we doing? We're trying to create a token from... We're trying to create a leaf token from a token. Why are we doing that? I feel like things are not what I was expecting. So, how did we end up in that try from there? It's because we call check token of type. Alright, it's because earlier in this process, we haven't correctly identified the type of thing it is, and now it's doing some kind of guess that it should be some kind of leaf, and it's not a leaf. I think that's what's going on there. So what we need to do is, earlier in our parsing process, when the first token that we hit is a curly bracket, we need to handle it. So parse next is our kind of entry point, and we say look for an expression where semicolon is like the end, the only end that we would expect. So look for an expression. An expression looks for a token, gets a token out, and matches on that token. And so far, it can only match on keywords the keyword let or the keyword while. We want to match on a new type of thing called brace open. And we don't care about its contents, and we're going to do something which is going to be calling self.block. Pass in those we're going to have we don't need the end markers, because when a block ends, we'll know that it's ended. But we are going to, and we don't even need the token. We probably do need the token for error handling, probably. So let's try just passing in token. Hold on, block already exists. Why does block exist? Because I guess when we were doing our while loop, we were expecting a block. We're dealing with blocks. All right, so we're going to pass in token.span because that's what block is expecting. And is this it? No, because that it's going to look for an opening brace inside block, and we've already found our opening brace, which is embarrassing, isn't it? So we could push our brace back in and then reuse this function, or we should make this function work the same way other similar functions work, where actually the first token's already been swallowed. So that would mean that here we have to say, so let's say expect block or something like that. That's what this function should be called. Right, because it's we haven't yet found the opening brace, but we know the next thing should be an opening brace. So get the next token, check that it's the right thing, and then do some stuff. And the stuff that it's going to do is going to be what we're now going to call block. And it probably will take in a token rather than a span, because it's not the previous token now, it's the actual token that is the beginning thing. So let's just say brace open, which are going to be some kind of, I don't know whether it's called token, we'll see. So here we're going to call brace, self.brace, block, self.block, and we're going to pass in brace open. And that's going to be what we return. And yep, this should return the same kind of thing that most of these functions return. And we are going to need that previous token span. Maybe we can just use our brace open span. I wonder what the right span is to pass into block statements. Where's it going to use it? So this is basically for our error handling, I'm pretty sure. The previous token span is to say unexpected end of file. Yeah, so actually it shouldn't be. It should be the span of brace open, because we know that token exists. So now we've got our block function. And we are calling it from here, and we should be just passing in token now. And does it now parse? It now oh gosh, that's a little bit too good that everything in my test was correct, given all the guesses about like locations of things and stuff like that. So we better check. What do we call this block? Parsing a block. Well, let's just change something here. Does our test fail? It does. So when we make it right, it passes. So we guessed that whole test right first time. Amazing. Well done us. So now we can parse a block. And that block might have any statements in there, and they'll come out, and that's okay because we check parsing of other types of statements in other places, so it's okay that this tests that. I guess the other type of block would be a block with no final expression because it's only statements. So that would be something like that with a semicolon at the end. Then we would put in something like this. So parsing a block without final expression. And this last thing here would just be, I think it would be, what would it be? A syntax tree of statement? I think we do this somewhere above. I feel like I saw that above. A statement which is, no, that was a block. Maybe it's this. I think it should be this. It's just a unit. The final expression is unit, as in like, it's as if we wrote something like this here. Whoops. Because that means unit. And now obviously we haven't actually written the code that does that yet, so, but yeah. It treats it the same as if there was just a unit at the end, which is kind of like in Python, where if you don't return anything, it treats it as if you return none. So it's kind of pleasing that it's familiar in some way with Python. Now, what is it moaning about? So the final expression part is right. It's a syntax tree of unit, like we were expecting. But something's off with... This is hard to read, isn't it? Okay, so anyway, it starts off fine. There's a 1 with a 2, 1. There's a 3 with a 5, 1. And then there's a syntax tree of statement of... No, yeah. Okay, so it should be... Yeah. It should look exactly like the other stuff. Instead of being a syntax tree leaf, it is a syntax tree statement, a box of syntax tree leaf. I thought that was a bit shorter than the others, didn't you? Let's just try to add some random brackets at the end, see if it works. Okay, it does. All right, so this is parsing blocks. That's cool, isn't it? And if we're really clever, we can also evaluate blocks. So what happens if we want to evaluate? So we had a to-do in one of our tests which was evaluating a standalone block that ends with a statement. So maybe now this should pass. No, I think it'll hit a... okay, that does seem to pass, so that seems bad. Let's just make sure it's running. Okay, yep, it does pass, so that's fine. We're already handling that case. So now what about evaluating a block with a final expression? It's got to be a bit of this. Evaluating a block with final expression yields value of that expression. This is too long, it's too long. Evaluating a block. Evaluating block, no, with final expression. Oh, let's just say value of block with final expression is value of that expression, right? Kind of makes sense. So it's going to be let x equal 3 and then ask for x. The value of that should be 3. Simple as that. And I guess we can also just do a number. We could even make it a floating point just for extra fun. 6.5 gives us a value of type F, 64, 6.5. If we're lucky. That seems really ambitious. All right, so run our test, and it fails because that doesn't yet work, because we haven't yet done the evaluating blocks code. So we had a to-do, which was evaluate blocks, or evaluate the final expression, final thing of a block. Yeah, that was it. So we refused to implement this, even though we knew exactly what to do, because there was no test. Now there's a test. We don't need that star, do we? Yep. All right, so go. Oh, lots of things failing. Because, yeah, when we call eval tree with a block, no, that does exist. All right, so why are we failing? Evaluator line 44. Evaluating unit doesn't give us anything, but it should. It should give us a value of type unit. An okay value of type unit. So I guess there's a few places where we evaluate that final expression in the block, and try and get the answer out, and we were not actually allowing that. If you found some syntax that says you're returning unit here and you want to evaluate that, you need to get out the value, which is unit. And all the tests passed, so it must be working. That's really nice, isn't it? So now we can write blocks. So let's try it. So we can write a block like let y equal 4, y plus 5, close the curly bracket, ask for the answer. The answer is 9. It works. So we're happy. So evaluating standalone blocks was almost already done because we'd done them for while loops. There wasn't a great deal more to do. So we can make a little commit there. Evaluate blocks ending with expressions as that expression value. Something like that. Gosh, that would be hard to read if you didn't already have the context. All right, so just to summarize what we did this video, we allowed you to write expressions that start with a curly bracket. Like, where do we do this? yeah, we allowed you to write expressions like this that start with a curly bracket, then do some stuff, and then end with a thing, and the value of that whole expression is the value of the last thing in there. And actually, let's just double check that that's actually what happens in our Rust test space, just to make sure that I'm not talking rubbish. So let's let A be a block containing a 50. When we run this code, should print out A equals 50, which it does. And let's just make it a bit cleverer than that. So let's say let x equal 4x plus 5. That's what we did before, wasn't it? So it should print out 9. And it does. A is 9 because this whole block evaluates to x plus 5 because that's the last thing in there. If we put a semicolon in, it warns us that we're not using some arithmetic. And the value of A is the unit value. Notice that unit value does exist in Rust just the same way it exists in Milk, our programming language, and it's written bracket bracket, which is also how you write the unit type. Anyway, hope you enjoyed that, and see you next time.